Welcome to the first video of Signals and Systems tutorial video sequence from pros and experts. This is a quick intro on this video series. We shall be solving all the questions from the book Signals and Systems, Kerala Technological University Question Bank and Solutions. Signals and Systems appears to be a difficult course to many engineering students, but I'm sure that's not true. Have a good understanding of the theory. This course is filled with a beautiful theorem and analysis waiting for you. The best way to master this course is to work out as many problems as possible. And why this book? I have selected this book not just because I have authored it, but questions on this course from this university never fall down from a standard. If you master these questions, you can face questions on signals and systems from any university or any competitive examinations. So subscribe to our channel and push the bell button for getting notified to every video uploads. So let us start. The first question in this video sequence. Given the signal x of t, sketch the signals. First one, 2x of minus 2t plus 3. Let's start the first question. We have to plot 2x of minus 2t plus 3. So from the question it is very clear that there are two signal operations on this question. The first one is shifting by 3 units and the second one is scaling by minus 2 units. So we know that if a signal operation consists of both shifting and scaling, the precedence rule tells you that what does it tell? It tells that first you perform shifting. First shifting should be performed, then scaling. Okay, this is what precedence rule tells us. So first from this question, you have x of t given in the question. Okay, first you need to find out x of t plus 3. Okay, then you have to find out from x of t plus 3 you have to find out x of 2t plus 3. If you are very experienced in doing the problems, you can directly find out x of minus 2t plus 3 from x of t plus 3. Otherwise you just find out x of 2t plus 3. Then find out x of minus 2t plus 3 and finally multiply it by 2. There's an amplitude operation and arrive at the answer. Okay, so let us start with solving this problem. Okay, this is x of t in the question. This is for 0, 1, 2, 3, etc. and this is at minus 1, minus 2. The amplitude here is minus 1. Here it is 1 and it is 2. All right. Now as per precedence rule, we have to find out x of t plus 3. So what is x of t plus 3? X of t plus 3 is nothing but shifting x of t by 3 units to left. Okay, shifting x of t by 3 units to the left. So what we will get is, the amplitude at the minus 2 is shifted to 3 units to left, so it comes to minus 5. So it comes to minus 5 in this signal. I can draw it as this amplitude comes here, then amplitude at minus 1 in x of t comes to minus 4 in x of t plus 3, and amplitude of the 0, this is the break at 0, it comes to minus 3. So it comes to minus 3 here, then 1 unit fall, then a straight line, and finally downfall. Okay, so clearly the amplitude at t equal to 2 comes to 3 units shifted, that is at t equal to -1 here. Okay, so the x of t plus 3 we have drawn is correct. Okay, there is 3 units shifted to left. And you have to note that the amplitude remains constant because what we have done is a time operation. There's no change in amplitude, right? Next we have to find out x of 2t plus 3, right? We have x of t plus 3 here. We have to find out x of 2t plus 3. It is scaling by 2, so the signal should be compressed by 2 units. So whatever be the amplitude at t values, the same amplitude should be as such drawn to that value divided by 2. Okay, so the amplitude at -5 goes to -5 by 2, that is -2.5, somewhere here in x of 2t plus 3. Okay, because the scaling factor is 2. Scaling factor equal to 2. We have to divide every time instant in x of t plus 3 by 2 to get x of 2t plus 3 here, right? So the amplitude at -5 goes to -2.5. So -2.5 was somewhere here. So this amplitude goes like this. Okay, now the amplitude at -4, this section goes to, this whole section goes to -4 by 2, that is -2, just here. Okay, let me draw that. So this signal, this portion comes like this. Okay, now this portion, this break at t equal to -3 will be at -3 by 2, that is -1.5 here. So the signal is like here. This is -1.5. Okay, now what about this portion? This portion was at -2, so in x of 2t plus 3 it comes at -1. So this is the signal portion. And finally the last portion, this portion at -1 comes to -0.5 here. Okay, so this is the signal x of 2t plus 3. This is -1 by 2. This is -1. This is -3 by 2. And this is -5 by 2. Right. So this is x of 2t plus 3. And now we can find, we have to find 2x of -2t plus 3. How will you find out x of -2t plus 3? This is just time reflection. You have to find or draw the flipped version of x of 2t plus 3 to get x of -2t plus 3. Okay, what is flipping or time reflection? It is just folding the signal about the y-axis. Okay, folding the signal about the y-axis. So flipping this signal gives you this value at -half goes to +half, right? +half here, right? So this amplitude goes to +half. Then next portion is at -1, that goes to +1, right? So like this. Then next interruption at -3 by 2 will be at +3 by 2 here. Then at -2, that portion gives to +2. Okay, now there is a shift here and the final value is at +5 by 2 or 2.5. Okay, so this is x of -2t plus 3. If it is x of -2t plus 3, then its amplitude should be, here it was 1, here it was 2, and this was -1. So no change in amplitude. Here it is 1, here it is 2, and this amplitude will be -1. But our question is to find out 2 times x of -2t plus 3. This 2 placed here is nothing but an amplitude operation. That means you have to double every amplitude in x of -2t plus 3 to get 2 times x of -2t plus 3. That means I have to write or double all these amplitudes and get 4 here, 2 here, and minus 2 here. Okay, so this is 2 times of x of minus 2t plus 3. Here it is half, this is 1, this is 3 by 2, and this is 5 by 2. Okay, so this is the final answer. Okay, now let us see the question B. So question B asks us to find out y of t, which is a sum of product of two terms, x of t into del of t minus 0.5 plus x of t into del of t plus 0.5. Actually, what is this del of t minus 0.5 and del of t plus 0.5? To be precise, del of t minus 0.5 is the impulse signal del of t, which is delayed by 0.5 units to the right. Okay, this is del of t minus 0.5. And similarly, del of t plus 0.5 is same del of t signal, which is shifted to minus 0.5 units to the left. Okay, right. Then what is x of t into del of t minus 0.5? X of t into del of t minus 0.5 means you are multiplying this signal x of t. I have drawn it for you already. X of t is multiplied by del of t minus 0.5. What is del of t minus 0.5? Del of t minus 0.5 is an impulse signal located at t equal to 0.5. This signal, and del of t plus 0.5 is an impulse signal shifted and located at minus 0.5, t equal to minus 0.5, right? So when you multiply x of t with del of t minus 0.5, that means this signal into this entire signal will give you a signal located only at t equal to 0.5. Okay, and that will be an impulse signal again. Impulse into any signal is impulse signal. So this output will be like this. Okay, so the signal will be an impulse. Now it is located only at 0.5. Okay, this is x of t into del of t minus 0.5, which is our first term. We are doing the first term, x of t into del of t minus 0.5. And what will be the amplitude of the signal or strength of the signal? It will be 1 into 1 is the amplitude of this or strength of this impulse signal, which is multiplied by x of t. What is the amplitude of x of t at t equal to 0.5? It should be 1.5, right? Because it is a ramp signal here, it will be 1.5. So we are multiplying 1.5 with 1. So the strength of this signal will be 1.5. Okay. So this is x of t into del of t minus 0.5, which is our first term. Now the second term is x of t into del of t plus 0.5. So that second term is added with the first term. So the result will be the same signal, which is located on the same axis. I can draw it. So this is del of t plus 0.5. Okay, it is located at minus 0.5. Sorry, minus 0.5. This is 0, right? And what will be the strength of the signal? The strength of the signal will be 1 for this amplitude, impulse, and 2 for x of t at the 0.5, minus 0.5. So 2 into 1 is 2. So the strength of the signal will be slightly higher strength here. Okay, so the strength is 2 here. So this is the final answer y of t to be obtained. We are actually adding this impulse whose strength is 1.5 plus this signal x of t into del of t plus 0.5 at minus 0.5. This is at 0.5 and this has a strength 2. So when you add these two signals, the result will be this signal. Okay, because all other t values are 0. Okay, so this is the final answer to question B. Moving forward to the next question. Check whether the following signal is periodic or not. If periodic, find the period. So the signal given is x of t equal to sum of two sinusoids, 3 sine 200 pi t plus 4 cos 100 pi t. Okay, so what we do is we have to find whether the signal is periodic or not. Only if periodic, you need to find out the time period of the entire signal. So here is the procedure. First, take the first term. Let the coefficient of t in the first term be omega 1. So omega 1 is 200 pi. And the coefficient of t in the second cosine term be omega 2. So omega 2 is 100 pi. Okay. So we got omega 1 is equal to 200 pi. And from omega 1, we can simply write t1 as 2 pi by omega 1, which will give you 2 pi by 200 pi, which is 1 by 100. Alright. And from the next term, we already got omega 2 as 100 pi. That will give you t2 is equal to 2 pi by omega 2, which is 2 pi by 100 pi, which is equal to 1 by 50. Okay, so we got t1 as 1 by 100 and t2 as 1 by 50. Now the total time period, before total time period, we have to check whether the signal, the whole of x of t, is periodic or not. If you take the individual terms, which is a sine term and a cosine term, sine 200 pi t is definitely periodic, cos 100 pi t is also periodic, but we are not sure about the sum of these two terms. To check whether this entire signal x of t is periodic, we have to find out t1 by t2. If this t1 by t2 appears to be a rational number, then x of t, the signal x of t, is periodic, otherwise not. Okay, so t1 by t2 is 1 by 100 divided by 1 by 50, which is equal to 1 by 2. 1 by 2 is a rational number. 1 by 2 is a rational number. Therefore, signal x of t is periodic. Okay, signal x of t is periodic. Now, what is the time period? What is the time period of this signal? The time period t is given by the LCM of t1 and t2. Okay, so that comes to be the LCM of 1 by 100 and 1 by 50. So our aim is to find out the LCM of 1 by 100 and 1 by 50. How will you find out the LCM of 1 by 100 and 1 by 50? Let me explain. So LCM of 1 by 100 and 1 by 50. To make this not a fraction, let me multiply both the numbers 1 by 100 and 1 by 50 by 100. So multiply by 100. I am just multiplying by 100. So this becomes LCM of 1, 2. What is the LCM of 1 and 2? It is nothing but 2, right? But that is not the final answer, because we have introduced a multiplication by 100 out of nowhere. So we have to divide by 100 also from this by this answer. So this becomes 2 by 100 equal to 1 by 50. Okay, so the LCM of 1 by 100 comma 1 by 50 is equal to 1 by 50, and that appears to be our total time period. Okay, so this is the final answer. But for students who are preparing for competitive examinations, let me show you a very simple method to solve this. Our signal is, let me rewrite our signal as x of t equal to 3 sine 200 pi t by 1 plus 4 cos 100 pi by 1 into t. Okay, Now just note the numerator inside the sine and cosine terms. Numerator of the coefficient of t inside the sine and cosine terms. The HCF, highest common factor of these numerators, will give you directly omega 0, right? HCF of 200 pi comma 100 pi will give you total angular frequency omega 0. Okay, so what is the HCF of 200 pi and 100 pi? It should be 100 pi. Okay, so omega 0 is obtained as 100 pi. Therefore, what is total time period t? T equal to 2 pi by omega 0, which is 2 pi by 100 pi, and it is 1 by 50, which is same as the answer we have previously got. Okay, so that's the final answer. Okay, we will hop to the next question, which is to obtain the system response of a system for the given input x of n, and you are also given the impulse response h of n. Okay, to do this problem, what we need is to understand the equation y of n equal to x of n convolution h of n. So you know that for an LTI system, if you give an input x of n and you know the impulse response or system response h of n, then the output is y of n, and y of n is given by x of n convolution h of n. So this is a discrete time system, so this is convolution sum. This is convolution sum. And how can you expand it? That implies y of n is equal to sigma over k equal to minus infinity to plus infinity x of k into h of n minus k. So in this problem, what we do is just realize this equation. So this is our prime equation. We are going to realize this equation. So what are in this equation? Y of n is there is an x of k here, h of n minus k here, and a product x of k into h of n minus k, and finally summing all the samples of x of k into h of n minus k. Okay, so we are going to find x of k, then h of n minus k, then multiply, then summate it. Okay, so first we are going to find out x of k. How will you find out x of k? This is very simple. You have x of n in the question, just change the index n to k, you will get x of k. Okay, then we have to find out h of n minus k. How will you get h of n minus k? You find h of k, then h of minus k. It's very simple to obtain h of minus k from h of k. Then find h of n minus k. H of n minus k is nothing but shifting h of minus k by n units. Okay, h of n minus k is shifting h of minus k by n units to the right if n is positive, and to the left if n is negative. We will come to that in the appropriate steps. Okay, now let me draw x of k for you. We have to first find out x of k. So what is x of k? X of k is nothing but x of n whose index is changed to k. Alright, so x of n is actually 3 comma, here is a comma here. Okay, so the first sample at n equal to 0, sorry, k equal to 0, the index is k equal to 0 is 3. Okay, then second sample is minus 1, then at k equal to 2 the sample is plus 2, then 0 and 1. Okay, this is x of k, right? Now x of k is over. Now to find out h of n minus k, first we should have h of k. Okay, so we will find h of k. We will draw what h of k is. I think I'll draw here. So h of k is nothing but h of n whose index is changed to k. Right, So the first sample at n equal to 0 is, k equal to 0 is 1, then 2 and 1. Okay, so this is h of k. Now we have to find out h of minus k. I will draw h of minus k here. How will you draw h of minus k? H of minus k is the time reflected version of h of k. Okay, so 0, and whatever is in 1 will be at minus 1, and whatever is at 2, the amplitude will be at minus 2. So at 0 we have the amplitude 1, at minus 1 the amplitude is 2, because 2 is the amplitude at k equal to 1, that will go to k equal to minus 1 because it is time reversal. And at k equal to minus 2 will have sample 1. Okay, so h of minus k is nothing but folding h of k about the y-axis. You can realize or visualize in that way too. So this is h of minus k. And what we need is not h of minus k actually, but h of n minus k. And h of n minus k is nothing but h of minus k shifted to n units. But if n is positive, you shift h of minus k by n units to the right. And if n is negative, you shift h of minus k by n units to the left. Okay. For example, h of 1 minus k. How will you find out h of 1 minus k from h of minus k? It is 1 is actually positive value. So you shift h of minus k by 1 unit to the right. So you will get like this, right? Okay. So this is h of 1 minus k. And in case if you want h of minus 1 minus k, okay, minus 1 minus k, you shift h of minus k to 1 unit to the left. So you will get h of minus 1 minus k as the signal, right? H of minus k is shifted by 1 unit to the left to obtain h of minus 1 minus k. So that is, I think that is clear for you. And now let us start to realize this equation. This is the prime equation of this problem, how to solve this problem. But before starting to solve this problem, we need to consider something. So we are going to find out y of n, right? Y of n. So how will you start y of n? That means at which n value do we need to start finding y of n? That is an important step to solve before we start this question. So that is given by a very simple idea. The idea is, if x of n starts at n equal to n1, and if h of n starts at n equal to n2, okay, starting time value of x of n is n equal to n1, and starting time value of h of n is n equal to n2, then y of n starts at n equal to n1 plus n2. Okay, so n1 plus n2 will be the starting n value of y of n. So we have to evaluate y of n at n equal to, starting from n equal to n1 plus n2. So in this problem, what is n1? Actually, x of n is 3 minus 1, 2, 0, 1. So it starts at n equal to 0. Okay, the first sample is 3, that starts at n equal to 0. So here n1 equal to 0. And what about h of n? H of n is having the starting sample 1, and that also starts at n equal to 0. So n2 is also 0. Therefore we can directly say that y of n starts at n equal to n1 plus n2. 0 plus 0 equal to 0. So in fact we have to start finding y of 0. Okay, you make use of this equation to find y of 0 first, then y of 1, then y of 2, etc. up to what? That is also given by the same idea. The end point of y of n. Where is the end point of y of n? Y of n ends at NA plus NB, where NA is the end n value of x of n and NB is the end n value of h of n. Okay. So here x of n ends at this is n equal to 0, 1, 2, 3, 4. So ends at NA is 4 plus where does h of n end? This is n equal to 0, this is n equal to 1, this is n equal to 2. So 4 plus 2 equal to 6. So we have to find up to y of 6. We have to find up to y of 6. Okay. Alright, we will start to solve this problem. So the first sample value will be y of 0. Y of 0 will be equal to sigma over k equal to minus infinity to plus infinity x of k into h of 0 minus k, right? H of 0 minus k. That means here it is a function of n. So if you have to find out y of 0, we have to replace n with 0 wherever n happens to be in the RHS. Okay, so y of 0 is x of k sigma x of k into h of 0 minus k, but h of 0 minus k is h of minus k itself, so I can write it as h of minus k. Okay, now we are going graphically to realize this equation to find out y of 0. So what is this equation? We have x of k here, we have h of minus k here, and we have to multiply x of k into h of minus k, then summate all the samples. Okay, so let me draw x of k first, then h of minus k, and then I will show how to multiply it. Alright, I have drawn x of k and h of minus k for you. Listen, I have drawn h of minus k right below x of k. Okay, in such a way that their n k values coincide. Okay, 0 k equal to 0 for x of k is right below k equal to 0 for h of minus k. That will be very convenient for your multiplication process. So here x of k and h of minus k. So according to this equation, what we have to do is multiply x of k and h of minus k. So how will you multiply? I'll draw this for you. I'm going to draw x of k into h of minus k. Multiplication is nothing but sample wise multiplication. You have to multiply corresponding samples at corresponding time intervals, time points. Okay, so at k equal to 0, what you will get is sample 3 multiplied by sample 1. Okay, amplitude is 3 and amplitude is 1, so the product is 3 itself. Okay, and now what is the sample at minus 1? It will be 0, because product of 2 and the product of 0 is going to be 0, and at all other points in plus 1 also, the amplitude here is 0 and here it is minus 1 will give you 0. So all other samples are 0. Only we will get 3 here at k equal to 0. So there is x of k into h of minus k, the product. Now what we have to do is find sigma. Do we need to find any sigma here? No, because there is only a single amplitude, so we don't have to sum it with any other thing. So the answer y of 0 is equal to 3. The first sample value is 3. And the next sample we need to find out is y of 1. We have found out y of 0, now y of 1, then y of 2, y of 3, y of 4, y of 5 and y of 6. Okay, so what will be y of 1? From this parent equation, y of 1, put n equal to 1, will be sigma over k equal to minus infinity to plus infinity x of k into h of 1 minus k. Okay, so y of 1 will be in a similar way. We have to find out x of k, that is here, no need to do anything extra. Then find out h of 1 minus k, then multiply it and find the summation. Okay, so okay, we have x of k here. Then now I'm going to draw h of 1 minus k. You know, h of 1 minus k is nothing but h of minus k shifted to 1 unit to right. Okay, h of minus k shifted to 1 unit to the right. We have h of minus k from the previous slide as this signal. This is h of minus k. So it is shifted to 1 unit to the right. So what we will have is sample 1 here, sample 2 over here, and sample 1 here. So this is h of 1 minus k. Now it is very simple to multiply x of k into h of 1 minus k. I'm going to draw the signal x of k into h of 1 minus k. Again, what we have to do is sample wise multiplication. So what you will get is amplitude 1 multiplied by amplitude 0 will give you 0 at k equal to minus 1. Then at k equal to 0, sample 2 is multiplied with sample 3, which will give you 6. So very large amplitude 6. Okay, at k equal to 1, what you will get is amplitude 1 multiplied by amplitude minus 1, which will give you minus 1. Okay, so minus 1. Then at k equal to 2, we have 0 here, and multiplied by 2 give you 0, and all other further amplitudes are 0. So in the product x of k into h of 1 minus k, you have 2 samples, 6 and minus 1. Okay, so what is y of 1? Y of 1 is sigma of the product. That means we have 6 here plus minus 1 here, that is 5. Therefore y of 1, our next sample of the output required, is 5. Okay, the idea is clear, I think. Now the next sample is y of 2. Y of 2 from the main equation. This main equation will give you sigma over k equal to minus infinity to plus infinity x of k into h of 2 minus k. So what we have to find is x of k, which is already there, and h of 2 minus k we need to find out. So this is h of 2 minus k, right? It is h of minus k shifted to 2 units to the right. Okay, h of minus k was the signal. This is shifted to 2 units to the right. So the first sample starts at k equal to 0. That is what is drawn here. Okay, now we have to find out the product x of k into h of 2 minus k, and that product will be 1 into 3 equal to 3 at k equal to 0, and k equal to 1, 2 into minus 1 is minus 2. At k equal to 2, we have amplitude 1 and amplitude 2. 1 into 2 is 2. Okay, in 3 we have both amplitudes 0, so the product also will be 0. In 4 we have amplitudes 1 into 0, 0, and all the further amplitudes will be 0. So this is x of k into h of 2 minus k. And so what is the final answer of y of 2? Therefore y of 2 is equal to, we have to find out the sigma of all these amplitudes, which will give you 3 minus 2 plus 2 equal to 3. So ultimately y of 2, our next required sample, is 3. Next sample is y of 3. From this equation, this is sigma over k equal to minus infinity plus infinity x of k into h of 3 minus k. Okay, so here x of k, h of 3 minus k is obtained by shifting h of minus k to 3 units to right. Then I have found out the product x of k into h of 3 minus k, right? At k equal to 1, we have minus 1 into plus 1, that is minus 1. At k equal to 2, we have 2 multiplied by 2 will give you 4. And at k equal to 3, we have 0 multiplied by 1, which will give you 0. So this is x of k into h of 3 minus k. Therefore, summating all these sample values, you'll get minus 1, plus 4 equal to 3. So y of 3 is 3. That's our next sample output. Next sample to be found out is y of 4, and that will be k equal to minus infinity to infinity sigma x of k into h of 4 minus k. So we have to find out x of k and h of 4 minus k. So this must be y of 4. So h of 4 minus k is h of minus k shifted by 4 units to the right, and that will end up in the signal. And this is x of k into h of 4 minus k, right? Minus 1 amplitude into 0 will give you a 0 at k equal to 1. Then 2 into 1 will give you 2. Then 0 into 2 will give you 0 at k equal to 3. And finally, at k equal to 4, 1 is multiplied by 1 to give you 1 itself. So y of 4 is the summation of these samples. That is 2 plus 1, which will give you 3. So y of 4 is also 3. Alright, the next sample value is phi of 5, which is from the equation sigma over k equal to minus infinity infinity x of k into h of 5 minus k. Let's see how it comes. Okay, if you find out y of 5 graphically, you will end up like this. We have x of k, then h of 5 minus k is obtained by shifting h of minus k to 5 units to the right. Or at this point I can say that h of 5 minus k is h of 4 minus k shifted to 1 unit to the right. Okay, this will also be a little bit easier because h of 4 minus k we had it in the previous step. So you just shift 1 more unit to the right, you will get h of 5 minus k, right? So this is h of 5 minus k, and the product of x of k and h of 5 minus k will be having samples at k equal to 4, which is the product of 1 into 2 give you 2, and no more. Okay, so the answer is just 2. So y of 5 is equal to 2. And the last sample y of 6 will be equal to sigma over k equal to minus infinity to plus infinity x of k into h of 6 minus k. I have drawn this for you. X of k, then h of 6 minus k is obtained by shifting h of minus k to 6 units, or you can find it by shifting h of 5 minus k to 1 unit to the right. So you will end up in this signal h of 6 minus k. Now on finding the product of samples, then we will be having a sample only at k equal to 4. That is the product of 1 into 1 is 1. Okay, so the answer y of 6 is equal to 1. So we have found out all the samples for the output, but we must be very sure about the question. Find the system response is the question. We have found all the samples, and it will be very good if you consolidated all these samples to the output, or else you can draw the actual signal y of n as it. Right. So to plot this signal, the signal is in n, variable n. So we're going to draw y of n. So what was y of 0? Y of 0 was 3. Then y of 1 was again y of 1 was 5. Okay, y of 2 was 3. Okay, again y of 3 was 3. We got it as 3 in the slide itself. Y of 4 is again 3. Y of 5 is 2. And y of 6 is 1. 6 is 1. So this is the signal, or you can write in sequence form. Y of n is equal to sequence 3, 5, 3, 3, 3, 2 and 1. So this is the final answer of this question.